All right, again, just so you see this, this is the email that I got this morning from Charles. Normally, Charles gets an email from somebody else. Now, this could mean a lot of things. This could mean that Don Pohl, who's the vice president of Rankin, happened to walk by some classes at the St. Louis campus and saw a bunch of people who were out of Rankin compliance. Could mean that. Could mean that it was just Charles and he saw somebody walking out of my class or one of the other classes this week that wasn't shaved or that, had the wrong kind of shoes or whatever. Again, believe me, Jeff does not want to play cop. But I am supposed to be looking at this every day. Because if I don't, then typically when Shannon comes in here, she does. I've already been called into her office twice and told that some of you are out of compliance. All right? I don't want to do that any more than you want to hear about it. All right, so that said, let's jump into Chapter 10, which starts on your book on page 423. Chapters 9 and 10 go together. Chapter 9 was on using classes and objects. Chapter 10 is an extension of Chapter 9, all right? And it is on an introduction to inheritance. Let me tell you that this is the plan. The plan is for the rest of the period today, however long it takes. It won't take 2.5 hours, but if it takes an hour, hour and a half, whatever, we're going to go over Chapter 10, all right? Then the rest of the period will be lab. Tomorrow, I plan on going over a couple inheritance examples with you, and by that time, I'll have figured out your homework as well. All the homework through Chapter 8, if you've turned it in, has been graded. Everything should be up to date now out on Inside Rankin, all right, as far as I know. If you find something that you think, well, you didn't grade this or whatever, then let me know, and I'll be glad to go back and take a look at it, all right? So here are our objectives. We want to learn about inheritance. What inheritance allows you to do is what's referred to as extend classes. You'll see that in action in just a minute. We've talked about public, we've talked about private, we've talked a little bit about protected, but you're going to see protected in action in here. In previous chapters, we've talked about overloading. Now in this chapter, we're going to talk about overriding. All right, they are two different things, although they are somewhat related to one another. When you work with inheritance, you are working with what's called an is-a or is-an existence. I believe that's on your test. So for instance, in the example that I gave you the other day where we had mammal, then we had dog, and we had cat, and we had pig, a dog is a mammal. A cat is a mammal. That kind of thing. If I created a class that was called vehicle, and underneath it I put cars, trucks, bicycle. A car is a vehicle. A truck is a vehicle. So when you've got an is-a type of relationship, that implies inheritance. All right? The grand poobah, so to speak, the thing that's up at the top of all inheritance hierarchies is what's called the object class. Not only are you going to hear about that in this chapter, but a year from now when we're in the Java stuff, you're going to hear about it again, because in Java it works pretty much the same way, where object is the top class. Then we'll talk about base class constructors, a little bit more, and some of you kind of asked me about this, but a little bit more about abstract classes. I would tell you, when we get to the point of talking about abstract classes, please pay attention. If you don't understand it, please read the book. Next week, I don't know when, I'm gauging right now, it'll probably be Wednesday, but next week you're going to have your hands-on test for chapters 9 and 10. You will have to write an abstract class and write classes based off of that abstract class. Guaranteed. There's only going to be one problem on the whole test, and it will be a console lab. So those of you who don't like GUIs, you don't have to worry a lick about GUIs. All right? Then, and Colin, you referenced this before, we'll talk about how to create and use interfaces. All right? And we'll also talk about extension methods. Extension methods are kind of cool. I don't believe that they're allowed in Java, but what an extension method says is if somebody else created a class, be it, let's say I'm working with all of you in here, and Amin created this class, and I'm able to use it, and it's really cool. It's got a lot of really good stuff in it, but I think, you know what, it'd be even better if he'd add this one method to it. I can then add a method to it. That's an extension method. You can also add extension methods to classes that are predefined. So if you're using a class that's a C# class, that's an actual C# class, you can add to it with extension methods. Then, as the author always does, talks about at the end how inheritance is also used in GUI apps. All right? It's important that as we go through this, if you don't understand something, that you ask. All right? If you still don't understand it, I'm going to say go back and read the chapter if you have not done so. All right? I know I sound like a broken record, but you're going to have to. All right? And in my opinion, whether it's right or wrong, but in my opinion, next semester, the class is harder than this one. We use C#, but ASP.NET is harder than just using C#. So it's going to be really more important next semester that you read the chapter. The good news is when we start that class next semester, the first thing we're going to do, the first 1, 2, 3, 4, I don't know, X, whatever number of weeks we get, we're going to build a website. All right, we're going to build our own website. And when we get, we're also going to incorporate into it Bootstrap. I know, again, BS for Bootstrap, and some of you hate it, but it's used. It's not going away. All right? All right. So, the author mentions that you're probably familiar with inheritance, but most people, when they think of inheritance, think of one of two things. Well, either, wow, I inherited a lot of money because so-and-so died. That's one thing. Or, well, he inherited his good looks or he inherited his bad looks. My daughter came up, my daughter is due now, in like 3 months. And this girl she knows who's very pretty, and her husband, who's a really nice looking guy, had a kid. And I'm sorry, but the kids got howdy-doody ears. They look like they're bad. They're really big and they stick out. It doesn't look like either parent. In fact, the pictures that the mom has, they always have a headband and they have it over the kids' ears. I don't know if they're trying to push them in or what. But, it's like I mentioned to you before. Now, she's all worried because I think she's a nice-looking girl. I think that her boyfriend's a nice-looking guy, but she's worried that's going to happen to us. And she tries, now she's already gone in and she's picked out all of her bad traits, and she's picked out all of her fiance's bad traits, and she's sure when you combine those together, that's what she's going to get for a kid. All right? And since he's 6'5", and she's 5'4", so she's sure since it's a girl, the girl's going to be 6'5". She's already got all this stuff is in her head. Right now, what I've been told is the kid right now is about not even as big as a ruler. All right? But it's going to be 6'5". But we'll see. All right. So the author says, again, when you think of inheritance, you think of either biology or whatever. It says, but you can also have inheritance in programming languages. Any programming language that's object-oriented or object-based allows you to use inheritance. All right? You will use inheritance in Java a year from now, and it'll be very, very similar. All right? If you remember before how I showed you that, we put that colon, I-comparable. That colon is used for inheritance here. You're going to see it in just a minute. The reason I'm telling you that is you use a colon, dot, dot, a dot above another dot. That shows inheritance in C#. In Java, you use the word extends. You actually have a word rather than a symbol. Other than that, it's pretty much used the same way. So the author says you already know how to create classes, and you know how to instantiate objects from those classes. So the author starts by giving you a non-inheritance example here on 425, and says this is something you should all be able to do now. You've got a class named employee. The class has two different variables, two different instance variables. So each employee will have an ID number and each employee will have a salary. Then we set up our property accessors. And you'll notice that with both of these, we're not doing anything, so we could have used the shortcut version on each of those. So we could have said ID num, I guess it would have been public, int ID num with a capital I, and we could have had the get set in curlies, and then public double salary with a big S, get set in the curlies. For whatever reason, the author didn't do it like that. All right? And the author is also expecting that in this employee class, you also have another method in there called get greeting. All right? That says, hello, I am employee number, and it'll grab that employee number, and it'll grab that, you know, I guess that's it. So they say that if you wanted to, then you could create a couple of employees. And once you created those two employees, all right, you could basically set for those employees, you could set what? Their salary and their ID number. That should make sense now to every one of you that's in here. All right? Then the author says, okay, that's all fine. But what if you have a new type of employee that you bring in, and the new type of employee not only has an ID number and a salary, but they also have a commission rate. So they're a salesperson. So we don't really have to start all over. We could, but if the new employee has an ID number and a salary and a commission rate, why should we start all over when we've already got this? So what we can do is we can make another class that's based off of this class. In other words, it will inherit what we have from this class. All right? And that's what the author is getting into next. Now, for whatever reason, she takes a little bit of a detour here and talks about this kind of diagram, which I may have talked about with you last semester. I don't remember. This is called a UML diagram. UML is an acronym that stands for Unified Modeling Language. And basically, it's all the information about your class broken into thirds. The top third is the name of your class. The bottom third are all of the methods that are in the class, and the middle third are all the instance variables. All right? So that's what the author is telling you, for whatever reason. All right? And the author says that, you know, you might want to use that because it's a graphical tool. There are actually tools that you can buy, software tools that you can buy. They're not free, but they will take your UML diagrams and they will create code based off of them. There's also other software that you can buy that will take your code and make UML diagrams out of them. UML diagrams are known as external program documentation. They don't exist in the program itself, but there's something that you could show to an end user, to a manager, or whatever. It's a graphical type of tool to try to explain what it is you're trying to do. All right? So the author says that when you actually use inheritance, this is the middle of page 426, these are the three basic benefits that you get. First, you save time. You don't have to recreate because you've already got most of the stuff you need in another class. Second, you reduce the chance of errors. Somebody has already tested this stuff in the employee class. It's not that you don't have to retest it. You want to make sure your code didn't break it. But the chances are pretty good if you wrote it correctly and you follow the guidelines that it didn't break it. And then finally, you make it easier for somebody who's already used the employee class to start realizing that the commission class is just another employee. So again, from the examples I gave you before, what we're saying is if you come here, usually it's drawn in a box, and you've got employee. And you say that all employees have what? They all have an ID number, and they all have a salary. All right, and they all have that get greeting method. All right, now we're going to come in here and we're going to make a commission employee. So the commission employee will, depending on how you set this up, will either directly or indirectly be able to access the ID number and the salary and the get greeting. What's different is for the commission employee, they'll also have a commission rate. Okay? Does all that make sense taking a look at it? And this is another example. A commission employee is a employee or is an employee. That's that is a relationship that we talked about before. Yes?
So with that, would the employer also have the commission commission rate, or is it only
No, that's a good question. Anything that the parent that's defined a parent is going to be available directly or indirectly to the child. But anything special that you put into the child is not available to the parent. It's known as a transitive relationship. So it's one way. All right? That's a good question. Okay. So in your UML diagram, this would be your employee. And notice, because that's actually a symbol in a UML diagram. You use different kinds of arrows, and that's an arrow that the tip is colored in. So what that means is commission employee inherits from employee. So it automatically gets everything that's in here. It may not be able to access it directly, but it can access it. And it's going to add its own commission rate that'll have its own get set. All this stuff, here's a warning. This page right here, 427, start marking it up. All this stuff's on the test, directly or indirectly. I think directly. All right. Employee here is called a base class. It's also called a parent class. It's also called a superclass. So I would know all three of those terms. Base class, parent class, superclass. All right? Now, I'm going to say something that's a derogatory term, but in older textbooks, they would also call it a master class, and they would call the other one a slave class. We don't use those words anymore. The reason I'm telling you is if you look in an older textbook, you might still see that in there. All right? But it's base class, or it's parent class, or it's super class. That, for example, is employee right there. On the other hand, if you look at commission right there, that's called a derived class, or an extended class, or a subclass, or a child class. All those words are sprinkled throughout. And I will tell you, because I've graded everything but the middle 2 pages of your test, and a bunch of you mixed the stuff up. All right? And I'm sorry about that, but that's just the way that it is. This is terminology that you have to become familiar with. If nothing else, if you remember parent-child, all right, or base-derived, however you want to remember it, but you have to be able to remember it. And they give you a lot of other examples like I've given you before with like dog and then different types of dogs, or mammal, pet, dog, cat, pig type of thing. They give you examples like that. All right? And they say that the entire list of parent classes from which a child is derived constitutes the ancestors. So in other words, if let's say that I came in here, this is a dumb example, but let's say that I had both a full-time commission and a part-time commission, all right, type of thing, all right? Then their ancestors would be both commission and employee. It's just like your ancestors, all right? It's your parents, it's your grandparents, it's your great-grandparents, your great-great-grandparents, etc. The idea is the same here. And this goes back to what Brady had asked. Inheritance is transitive, which means that a child inherits everything from its ancestors, but it doesn't work that way in reverse. All right? This understanding inheritance here that's on 428, the author is just repeating what she already repeated earlier about some of the benefits of inheritance. All right, so this is the magic. Again, it's the colon. So this means you say class, then you put the child class, colon, then the parent class. Does that make sense? Don't do it the other way. Don't say class employee, colon, commission employee, because that would mean that an employee is a commission employee rather than a commission employee being an employee. If this confuses you, look at it this way. Remember, it's an is-a. So commission employee is a employee. If you remember that, you'll put it in the right order. Now, you don't have to do it like this, but notice, because sometimes people do this. Notice how this is employee, so that's not commission, it's commission employee. See what I'm saying? Sometimes people do that to show the hierarchy. The problem is if you get 7 or 8 layers deep, you don't want your name to be 100 characters long. All right? But sometimes people do that just because it's a little easier for them to understand or whatever. You have a question?
Yeah, is that like when you create a class, is the text that's already inserted at the top where it says class and then your class name? Is that what you're putting?
It's, what I'm saying is, when we came in, when we've created our own new classes, okay, now what you're going to do is you might come in here, if we look at, if we brought this example up, and I mean, this is a dumb example of what I'm going to show you, but it'll at least show it to you. So this is the one that I had just shown you here. All right, so we've got our person class. So if I decide that I'm going to make a male person and a female person, got a dumb example, but it's just popped into my head. So if I right mouse click on here, and I would choose add, new item, and class, and let's just say we do the female here. All right, so female.cs, there it is. So what I'm saying is there you're going to put like that. All right, so that means that a female is a person. Okay, so now the female will either directly or indirectly, all right, be able to access everything in the person class. All right, but when you think of some things, for example, I'm not trying to be funny or crude or anything here, but the ability to have children. To my knowledge, males don't have that ability, at least not yet. Females do, so I might add something like that to this class because it would be unique then to this class. But this class, the female class now, will either directly or indirectly be able to access all of this stuff. Because like males, females have a first name, a last name, social security number, height, weight, eye color, hair color, and gender. Does all that make sense? All right, so again, you see the syntax for it. So notice what they have here. This is the commission employee class. It has what? One piece of data. Commission rate, that's a double. All right, and that double has a get and a set. Again, we could have used the shortcuts there. So when you do all this stuff, all right, it says when you write a program that instantiates an object, you can use any of the next statements to set the field values. So notice that even though ID number and salary, even though those were set in the employee class, you can use them here. All right. What's new is this commission rate. Now, they didn't use it for whatever reason. I think the author's trying to keep this simple, but normally, a commission rate is based on something. For instance, how much sales you have. So I would have added another field in here called sales, and then I would have set the commission rate and set basically your actual commission would have been your commission rate times your sales. The author didn't do that. I think the author's just trying to keep this very simplistic. I don't know, but that'd be my guess. So as it says, the salesperson, which is type commission employee, has access to all three set accessors. Two of those are from the parent, the ID num and the salary, and one from its own class, because a commission employee is an employee. If I tried to come back and I tried to create just an employee, I could set their ID number and their salary. If I try to set a commission rate for somebody who's an employee, not a commission employee, but an employee, I'd get an error message. All right? This all goes with stuff we talked about the other day, that the higher up you get in the hierarchy, the more generic you are. The lower you get in the hierarchy, the more specific you are. And again, I said it's like writing an outline. So maybe the first time you ever wrote an outline, whatever grade that was, you might have had one Roman numeral. And underneath that, you might have had an ABC. And underneath the B, you might have had a 1, 2, 3. And underneath the 3, you might have had another ABC type of thing. So you're going from very general to more and more specific. That's what you're doing when you create a class hierarchy. And quite often, the higher up you get in the hierarchy, those classes will all be abstract. You'll see that later on in the chapter. But that abstract means that you are not able to create instances of those classes. All right? That's why I'm saying if you're listening and you're thinking, okay, I'm listening to you, but it's not making a boatload of sense, then you better go back and read the chapter. That's all I can tell you. All right, so they show here in this example, they create a clerk who is a type employee, and they created a salesperson who is of type commission employee. So notice with a clerk, you can have an ID number and a salary, but for the salesperson, an ID number, a salary, and a commission rate. And they show what this is. And they say here, again, don't do this. Don't go back to the employee and give them a commission rate. You're going to get an error message if you try to do it. It's invalid. If you notice in here, I have not looked at these, but the author, again, has got a video on inheritance. She's got several videos in this chapter. If you don't understand what you're getting from what I'm giving you, read the book. If you still don't understand it, I recommend looking at what she's got in there for examples. There are a lot of really nice websites out there too. All right, there's C# Corner, and there's a few other ones. If you go and look up C#. All right. There's also a really nice online textbook, and I probably may or may not have shown you this, but if you go out to tutorialspoint.com, they've got tutorials. They've got a tutorial library on all sorts of different stuff. If I go to programming, you'll notice if I look somewhere in here, there's C#. All right, and you go to PDF version, and you go to PDF. You don't have to pay for it. They ask you to, but I never have. All right, and if you go there, so if you go to this right here, all right, if you go right there, that's another place that you can look. Just tutorialspoint.com, C# tutorial. All right. What these are their short little bites of information on things. They'll explain something to you in a page or two and then show you an example or two. So if you don't like what you're getting in the book, all right, that's another thing that you have available to you. And I've got to remember that within the next week or two, we're almost to the halfway point, I have to do another course, my course evaluations, not the one that Shannon does. And in there, tell me what you think of the book. All right? I will tell you already, and one thing I'm finding out about him, I really like Evan Gudmested. He's a super good guy. But once he gets comfortable with a book, he doesn't like to change. This is one of the first things he said when we talked was, you don't want to change the HTML book or the JavaScript book or the C# book for next year, do you? And my response was, I think people like the HTML book. I don't think they were nuts at all about the JavaScript book, and I don't know yet about the C# book. All right, but we got to go by what your comments are on this stuff. If 9 of you do this, and all 9 of you say, this book really stinks. All right, the bad thing is in December of 2016, we had to put in the books we're going to use for next school year. So it's going to be used again next year. But if people basically totally hate it, I will let them know that and say I think we should change to something else in the future.
Did you guys change the JavaScript book?
He didn't want to change any books. And since I've only been here 8 months, I'm not trying to rock the boat. All right, so I said, but one thing I found out that he did that I didn't do is with you guys, I went through like the first 8 chapters, I think. He went through the first 5 chapters. And then he went over a later chapter, I think it was 9 or 10 on jQuery. But he skipped all the stuff that he had first told me to do. He's like, no, you don't have to do that. Then tell me that stuff, please, when we're at that part of the class. All right, because I'm going by what he's got on here. He's like, no, I didn't do it. I didn't do a lot of that stuff. Okay. All right. So there's an example, all right. So these 2 truths and a lie. You should know that that would be the lie right there. Pet is not a type of dog. Dog is a type of pet. So that's backward. That should be public class pet, public class dog, pet. All right? Now there's an example in this chapter it's a car loan example, or some kind of a loan example that they keep adding to. So again, if you don't get this, all right, I don't know if you've got access to the actual programs that are in here like this. If you don't, let me know, and I'll put them out there. All right, but there are really good examples. She does a pretty good job. She always starts real slow and then builds her way up and works on it. That's all you get for that first example. Loan number and the loan amount. But she keeps adding to it as the program or as the chapter goes on, and I think it's done pretty well. All right, we've talked about protected. There'll be more on the next test about protected. So if I define something in here and I say it's private, once it's been set, the only way I can change it is in something that's in here. Even though that this is a child, if it's defined up here as being private, I can't change it after it's been set directly in here. I can't. All right, remember what we said about private? Basically only directly accessible in the class in which it's defined. If I define something in here, if I define these two things and I make them protected, that means I can change them here or in any child. All right? So if something is public, anybody can change it. If it's private, it can only be, it's got a very limited place that it can be changed. And if it's protected, the parent can, the child can, the grandchild can, the great-great-grandchild can, etc. That's the main distinction between those. And that's what the author talks about in here. But again, you should strive not to make everything protected. Why? Because that means that anybody can change it. Anybody in the class hierarchy can change it. All right, so even though you can do it, you should do it with reservation. In other words, you should do it and think about first whether or not that's exactly what you want to do. That goes against the ideas, the true ideas of object-oriented programming. There are actually object-oriented programming languages that don't support protected, because they say that that violates what we're trying to do with object orientation. All right? Java has it too, just so you know. This stuff is that you're seeing here will totally run true for Java. So the author says, on some occasions, this is on 435, on some occasions you do want to be able to access a parent class from a child class directly, all right? And they give an example here. So the author says to do that, they give you different ways that you can do it. It's important, this is not on the test, but it's important for your understanding to read the stuff on 434, 435, and 436 that goes over protected, so that you have an some kind of an idea of what the author is talking about. It's not directly on the test, but I'm sure that I'll set something up so something will have to be protected on your hands-on test. So the author says, what you basically want to do is this. If you remember, in our employee class, we had a salary that had a get set in there, okay? And then in our commission class, we had just a commission rate. But the author says, what if you want to do something like this? So what if you want to say, you know what? If a person last week, let's just say that they're for annually, that if the minimum amount that a commission employee can make, for example, is 15 grand. So if they make less than 15, we're going to supplement them so that they make 15. All right? And the author shows you different ways that you can do this, but then says, guess what? That won't work, that won't work. All right? So they say that if you use a public set, it doesn't work because of the minimum requirement. If you make it private, it won't work because it's inaccessible. If you make the actual parent class public, it would work. All right, if you make the field public, but that would violate information hiding. Remember, you have your fields private for information hiding, because it goes back to what I mentioned before. If you make your fields private, that means the only way that you can access those fields are through public methods. All right? So the author says the way you can get around this is to use what's called protected access. As it says, it's sort of public, sort of private. All right? It's public, but to everybody in the family, so to speak. To the parents, the grandparents, you know, whatever. Wherever you define something as being protected, from then on down in the family tree, it's available directly to all. All right? And that's exactly what protected means. So they come up to the salary field, and they make that in-class employee. So in the parent, they make that protected. All right? It's not changed inside of the employee, but it will then be able to be changed inside of the commission employee. That's where they're changing it. It wouldn't have worked otherwise. All right? And they go through a whole long example on 438 in the book. They give you a little mini program to show you, to prove to you, whatever way you want to look at it, that it works. All right? All right. Page 439, overriding base class members. And I've given you this example before. This is a non-computer example. But I've given you the example before where I said, Mother A, Father B have baby C. Mother A and Father B have big noses. Chances are pretty good baby C has a big nose. And it's not like the baby C can just pull that nose off and put on one they'd want. But if they could, that's what overriding is. All right? If you override something, what you're saying is you've got something that you defined in a parent that you have to change, either add to or whatever, in a child. All right? Do you remember when we did overloading? And we looked at something that looked like this. I gave you this example where we had add to, and we had int n1, int n2, and we said, so this was like public int, and then return n1 plus n2. All right, we did that. And then we looked at public double, add to, double, n1, double, n2, return n1 plus n2. The idea, and I know it's kind of hard to read, but it's this. There's one method declaration, there's the other one. Remember when we said that whatever's in the parens has to be different between the two? That's overloading. When you override, that means I want to take this that was defined here, for example, and I want to redefine it down here. When you override, the method signature must be the same, not different. If they must be different, it's overloading. If they must be the same, it's overriding. All right? And that's what they talk about in here. They also use the word polymorphism. So again, if I create an example that looked like this is something similar to what I showed you before. If we said mammal, and underneath mammal, we said dog, and we said bird, and we said pig, as an example. And up here, I created a method that was called speak. All right? Well, I'd create this method called speak, but it wouldn't do anything in here. In here, my speak method would say woof or bow wow or whatever. This one would say tweet. And this one would say oink. So in other words, in the parent, I could define a method, and then I could override the method in any of the child classes. When you override those like that, all right, you're doing what's referred to as polymorphism. Polymorphism is a Greek term that stands for multiple forms. All right? If I call speak, the system will know, oh, it's a dog, so I say woof. If I call speak, oh, it's a pig, say oink. So it knows which speak method to call based on the type of object you're working with. And if that makes even a little bit of sense to you, then you're on your way to understanding this. If it doesn't, again, I'd start by reading the chapter. And they give some examples. It says, although both a guitar and a drum are musical instruments, if you wrote a play method for each one, it would be different. You don't play a drum the same way you play a guitar. You don't operate a bicycle the same way you operate a truck. All right? As it says, for satisfying graduation requirements, it's much different in a college. It's much different in a college than it is in a preschool. All right? So they go through an example here where they use tuition type of stuff. All right? Now the key word here, if you look up on the screen, is that word virtual up there. If you put the word virtual before a method, if you put the word virtual before a method, that means that that method is overridable. That means that later on somebody can override it. You have to use the word virtual. All right? And then later, if you want to override it, you use the word override. So they work in tandem. So the parent would have the word virtual in it, the child would have the word override in it. But if you look, all right, public override int credits, public virtual int credits. See that other than the fact that one says virtual and one says override, they look the same. They have basically the same types of signatures. When you do this, what happens is, and I think this is on the test too, but I don't remember, on 441, as the author says, the child hides the parent. So if you've got two things by the same name, the child is in essence hiding the parent. Sometimes you don't want that to happen. Sometimes I want the child method to call the parent method. Did you hear what I said? It would be like, I can't think of a reason for it, but it would be like I wanted the bird speak to call the mammal speak. And if you want to call the parent, in Java you use the word super. Here you use the word base. Remember base class? You say base dot, and then you can call the one by the same name in the parent class. But if you don't, as it says, what's in the child hides what's in the parent. A base class member that is not hidden by a derived class is visible in the derived class. All right. I'll go for about 5 more minutes and we'll take another break because this is heavier stuff. It really is. And like I said, to me, you have to read it in order to be able to understand it. All right, so what we'll probably do tomorrow is, again, we'll go through a simple example, then we'll go through a more complex example. All right? I also don't want to give you too many examples. First of all, I'm screwing up their paper budget here by printing out all this stuff like I'm doing. All right? But the problem is, you might say, yeah, why are you doing that? Because if I give you hard copies, I know what at least some of you, and this is not to be accusory, but I know what at least some of you would do. When it comes to a test, you try to grab that one that I gave you and manipulate it to make it work. All right? There's also something to be said to giving you a hard copy and having you type it in. You make your own errors then, and you have to figure out what's wrong with something. That's how you learn. All right. So to access base class methods and properties, see that? That's what I mentioned before. Base dot. That means parent. Call the one of the parent, in essence, is what they're saying. And you'll notice here on the bottom of page 444 that, again, the author has, as mentioned, another video on this stuff. All right. I haven't watched really any of her videos, so I don't know if they're good or not. Now, under the you do it, if this is confusing you, I would suggest This is the same you do it that they had earlier in the chapter where they had that simple car loan, but now they're adding to it. It says in the previous sections, you created a loan class, all right? And again, I'll look during the break, but I've got these here, all right? These are in the student files. You should have a folder for each chapter that says code and figures, all right, for each chapter, and those are the ones that are right from the chapter. So if you want to look and see what they've done in the book, and well, I don't really have time to type those in, well, then you don't have time to type them in, but you can at least look at what's in here. All right, this is actually a good place to break because implicit references is a whole nother topic. So it's 10:03, let's come back around 10:15, please, and we'll pick it up there.